So welcome to this machine fault diagnosis course. Today's topic is principal causes of failure in machinery. The contents of the presentation is misalignment, unbalance, resonance, bearing failure, gear failure, looseness. So these are some of the common machine failures that we are uh, discussing today. Okay, so these are the basic machine failures like misalignment, unbalance, resonance, bearing failure, gear failure, looseness, etc. etc. So we start with misalignment. So misalignment, whenever the two shafts are transmitting power from one side to another side, then these shaft has to be aligned uh, within the tolerances. But because of different reasons, because of the installation errors, because of uh, the looseness in the foundation, or because of the soft foot of the machine, this alignment get disturbed, and because of that, the machine starts vibrating or machine starts generating noise. So such type of problems are called misalignments. Now there are different types of misalignments like parallel misalignments or angular misalignments. Parallel misalignments generates uh, the different type of frequency, and the angular misalignment generally generates different types of frequency in different directions. Like angular misalignment generally can be observed in axial direction, whereas the angular misalignment, sorry, uh, the radial misalignment, parallel misalignment, they can be observed in radial directions. So uh, if the shafts are not properly aligned, then that is termed as misalignment. Now, the principal causes of misalignments are lack of appropriate standards and specifications, poor tolerance and poor methods, good methods but bad practices, lack of understanding of precision process, dynamic movement, thermal growth, pipe strain, etc. etc. So misdiagnosis with unbalance or looseness. Okay. So these are some of the causes, uh, principal causes of misalignment. The next is unbalance. So unbalance is inappropriate distribution of mass uh, uh, in the rotor. Okay, if the mass is not uniformly distributed from the center of the rotor, then the rotor get unbalanced, and because of the unbalanced, a lot of centrifugal forces, unbalanced forces are generated, and because of that, the rotor starts vibrating. So that is unbalanced. So if the width of the rotor is very less as compared to the diameter of the rotor, then such type of unbalance are called single plane unbalance. And if the rotor width is substantial with respect to the diameter of the rotor, then such type of unbalance are termed as multi-plane balancing. Okay, or it requires multi-plane balancing, because a lot of couple is generated apart from the centrifugal forces. The couple is also generated, and that is why such problems are to be tackled as multi-plane balancing problems. The principal causes of unbalance is accumulation of assembly tolerances, poor attention to assembly, inappropriate use of standards, non-homogeneous materials. If the materials is not like, most of the rotors are casting. Okay, these flywheels, these heavy rotors are casted, and if the distribution of material is not uniform along the center of the axis, then such rotors are unbalanced. Okay. So non-homogeneous materials, casting blowholes, they are the principal causes of rotor unbalance. Operational operational uneven built up of product. Uh, Sometimes, like for example, in ID fans, where the flue gases are gases are taken out from the chimney. Then sometimes these flue gases or the particles in the flue gases gets stick to the fan, and because of that, the rotor get unbalanced. Sometimes because of the erosion of the rotor material from one side creates unbalance. So these are some of the principal causes of unbalance. Next is resonance. Particularly the structural members are very prone for a resonance. So the structural design engineer take utmost care to avoid the resonance. Resonance is a phenomena when the natural frequency of the structure, the natural frequency of the structure matches with the excitation frequency, and because of that, the amplitude of vibration becomes too much, and because of that, the member fails. So such failures are called resonance, and it is up to the design engineers to keep the natural frequency of the structure very away from the excitation frequency. The principal causes of resonance are the matching of excitation frequency with the natural frequency. Then comes the bearing failures. So bearing failure itself is not a significant source of vibration until quite advanced stages of failure are reached. So unless and until there is some problem in the bearing, it doesn't generate vibrations. But if the problem persists in the bearing, then it give indication in the form of vibrations. The design life of a bearing is very dependent upon the service it in it. In some industries, it appears that fewer than 5% of the bearing achieve their design life. If the bearings are, because bearing are the component where entire, it supports the entire load of a machine. Okay, they they shoulders the entire load of the machine on their shoulders. So bearing is very critical component, and if it is not maintained properly, then it is, if it is not lubricated properly, if it is not maintained properly, then there are chances that the bearing may not complete its uh, prescribed lifespan. Okay, so as per the data, only 5% of the bearings, industrial bearings, achieve their design lifespan, because uh, whenever the shock comes on the machine, then the first component which get hurt because of that shocks are the bearings. So that is why bearings are very critical component, and it has to be maintained in a very precise manner. Then another very common machine fault, machine failure is because of the gear failures. So gears or gearboxes are very important component of any industrial machines, because it gives uh, it reduces the speed, at the same time it increases the torque, uh, and yes, gears are also very important. It also shoulders lot of torque, lot of load on their own. The principal causes of gear failures are misalignment of the gearbox internally and externally. Then soft put. Soft put is basically the foundation errors. If the foundation is not properly even, if the foundation bolts are not tightened properly, then such type of problems are called soft put. Gear tooth cracks or missing. So because of these shocking loads, the gear tooth may get damaged. Okay. Then bent shaft. So internally, these gears are mounted on the shaft, and if the shafts are bent, Uh, then also the interference between the two mating gears are not proper, and because of that the gear may get damaged. Then the next very common causes of machine failure is looseness. So looseness is nothing but looseness may be considered as being where parts are not fitted tightly together. Typically, this fits into three categories: structural looseness, weakness of machine feet, base plate or foundation, also by deteriorating, grouting, loose hold down bolts at the base, and distortion of the frame or base. This may be seen as a softwood. So looseness, excessive clearances between the two uh, joining parts, then such type of problems are called looseness. So loose plumber block holes, cracks in the frame structures or bearing pedestals, improper fit between component parts, excessive clearances in the sleeves or rolling element bearings, impeller loose on its shaft. So these are some of the examples of looseness. So looseness is also one of the very important cause of machine failures. So in this way, we have seen some of the causes of machine failures like unbalance, then resonance, then uh, shaft misalignments, looseness, bearing faults, gear faults. So all these are very common machine failures that you may come across in any industry. So 90 to 95% problems, machine problems, comes in these categories only. So thank you very much. Thank you.